All right. In this episode, we're talking to Manxing from Talkwalker about all things AI and data science. So, Manxing, to start off with, tell us about yourself. What's your background? How'd you get into data science and machine learning?
Yeah, so thank you for inviting me. So my name is Manxing, and I did my bachelor and my master in telecommunications engineering, actually. And then I did my PhD here in Luxembourg in machine learning. I started doing data analytics projects actually for my master thesis. So I did in Research Institute of Sweden, RISE. So in that project, I analyzed YouTube users' watching behaviors and discussed the potential gains of caching the popular content in the local proxy cache for an efficient content distribution. Even though there was no machine learning related in the project, but that's my very first step entering this domain.
Gotcha. That's very cool. So, you would be telling telecom providers what to cache to reduce bandwidth strain?
Yes.
Okay, very cool. And did that go into production?
No, not really. No.
Gotcha. Okay. In terms of data science environments and things, what's your favorite environment for working? Jupyter, RStudio, and why?
So actually, I use Python all the way,
Mhm.
but sometimes for a very quick experiments or for data visualization, I use Jupyter Notebook.
Okay. Why would you? So what do you do your Python development in? Is it just a straight text editor?
No, I use PyCharm.
Okay, very cool. In terms of how do you decide when to do something in a notebook versus when to just write up straight up Python code?
For instance, if I just want to quickly show, let's say, take a look at the data and to see the distributions of the labels or to see some examples to check the features and so on. So that I would use the Jupyter Notebook. And
Okay.
to carry out like running experiments, I will switch to PyCharm. Yeah.
Okay. So talk a bit about what you do for Talkwalker.
So I joined Talkwalker actually almost 2 years ago. And so in our data science team, we mainly work on, of course, finding AI-driven solutions for our products, ranging from image processing to natural language processing, both for text and for audios. And for me, I have worked on improving our document type classification model, particularly to identify news or blogs or forum sites, among others. And the rest of the time, I have been working on NLP-related projects, mainly processing text. And but that's work in progress, and these are not publicly released yet. And also, I'm also working on some more, let's say, practical issues. Let's say, how do we serve our model efficiently and to meet the requirements of the production environment?
Can you talk a bit about sort of the evolution of natural language processing? Like I think pretty much everybody started with a bag of words, and just doing very simple tokenization. And where is the field today, and how do you see the most recent big models like transformers? How do you see them being used?
So this like big models, like for example now very popular ones, transformer based models. The most interesting part for that model is it used this contextual embeddings instead of bag of words, which only embeds each words like independently regardless the context. So in that case, one word would have only one embedding. And for contextual based word embeddings, So if one word has multiple meanings, and they will have multiple embeddings accordingly. So it has a lot more potential, and it understands the semantic meanings of the word. So it would help us to solve many real world problems.
How does that work with stuff like, for example, like hate speech and abusive language?
So for that, I think we have, we call them like noises. We have our noise control. So we will also, of course, train our model based on the context, and then to understand the meaning and then identify them. And then, of course, in our training data, I think before we do other tasks, we would do this noise control. We will try to filter out these noisy data first, and then we continue with other analysis.
What if somebody wanted to specifically study like hate speech, for example? Would they have to have a separate model that was trained specifically for it?
Not necessarily, but I would say we provide general models. But if you want like a really domain specific model, it is also possible to train your customized model. Yes.
How much horsepower does it take in terms of compute power for working with some of these models, like BERT or GPT, the GPT family, or the the Elithor AI family? Is it something that a technically savvy person could do on a modern laptop? Do you need cloud architecture? Do you need a room full of servers? For like epic training time, what's the overhead on these models?
So I think, if I'm not wrong, I think some models, if you load them, it could take up, let's say, 512 or like 1 GB memory. And I think normally if you just want to run like a base model, it's a modern like laptop can afford it. But of course for us, we use like bigger GPU servers. Yeah.
Gotcha. Okay. What are some of the more interesting machine learning challenges you're working on right now?
So in general, the most challenging part is, for instance, how do I assign labels to unlabeled documents? For instance, if you have a predefined set of topics and you have tons of documents, how do you assign the topic for each document? So a very naive approach would be, let's say, we find a few keywords related to the topic, and then we could do keywords matching on the documents. And also, of course, if you want to go a bit one step further, you want to find the embedding of the document, and then you want to compute the similarities. And of course, when you choose the model, how would you compute the, let's say, the document embedding? Would you compute word embeddings and aggregate them, or would you compute based on sentence? So there are multiple choices. And also, how do we, for instance, of course, we deal with global data, and then the documents would be in multiple languages. And how do we deal with that?
Do you find, like, is there a substantial difference in terms of performance between using the more complex embeddings, like from a transformer model, versus just using bigrams? Sort of going back to the naive approach, but using bigrams.
I never tried actually, but I think because, for instance, if we want to, let's say, find something related to Apple, I guess it's a rather naive word embedding models wouldn't understand, for instance, between the real fruit apple and the Apple products, right? So I think that would be a challenge. And right now, I think the big, more complex models, it can, because of the contextual embedding, and it can understand the meaning of the words, so it's more powerful and more accurate.
Okay. Describe your exploratory data analysis process. When you get handed, say, a new data set, what do you do? What's your recipe for unlocking value from a data set?
So take this text data, for example. We would check the source of the data set and if it matches our problem or not. Because, for instance, if the data is from social media or is any like domain specific data, or it's from a news website and so on. And of course, when we do data cleaning up, and we need to maybe translate the emojis into text and also remove some user account information. And also in this process, we need to try our best to debias the text as well. And of course, we need to also check the label distributions and to see if any of the class, if any of the group is significantly we have significantly more data than the other groups and so on. And also, we can always run some simple baseline models on it and to quickly check the results and also identify, let's say, the misclassified documents and to see in which class we perform better and which class we perform worse.
Talk a bit more about, you said debiasing the text. What does that mean?
So, for instance, one example is emoji comes in different gender and in different skin colors and so on. So when we want to translate the emojis into text, we will remove the gender and the racial related text and to keep it as neutral as possible.
Are there cases, though, where those factors would be useful?
Yes, I guess so, but that is also always a trade-off.
Mm-hmm. So somebody who needed that data would have to do that data analysis separately outside of the environment you're talking about.
Yeah, I guess so, yes.
Okay. Why is that step in there? I'm curious as to like the decision-making process about why that's important or not important.
Because I think right now we don't want to make assumptions, or we don't want to confuse the model, and it's very important to keep our data set neutral and clean. We don't want to introduce too much like bias into the data, so the model may pick it up and may focus on a wrong, let's say, feature in the data to make the decision.
Okay. You mentioned labeling of sources and documents. How do you differentiate? Because there's a lot of, I guess, blurry lines. I'll give you an example. My personal website is listed in Google News. Right now, it's a personal blog. I would argue it's probably not a news source, even though it shows up in Google News. How do you differentiate between news sources and some random guy's blog?
Yeah, that's a very, very good question because it's very difficult for us as well. We actually work very closely with our product team, and then we give a rather like detailed guidelines to label our data. For instance, let's say if the in a personal blog, if you are talking about news in a very objective way, and then we may classify it as news, even though it's published on your personal blog site. So yeah, it also depends on what our like clients want. So I would say it's we need a rather clear, in detail guideline to label our data.
How do you deal with objectivity issues? I'll give you an example. Most of the planet agrees that Russia illegally invaded Ukraine, right? It's generally accepted as true. If you go to the official Russian news website, RIA Novosti, it's a completely different story. It's basically Kremlin propaganda. But RIA Novosti would be classified as a news source. It is literally the state is the government official news source, just like the BBC is the government official news source of the United Kingdom. In cases like that, how do you deal with a site that is theoretically accredited but is completely disconnected from reality when you're talking about news sources and classifying something as a news source or as propaganda?
Yeah, so in this case, I guess it depends on what you want to use this, how do you want to use this data? So if you want to use it for instance, sentiment analysis, then I guess your data is highly biased. So I would say we will like exclude them from our training data because it's it's highly biased.
Okay. Go ahead.
I don't know. It's okay.
In terms of sentiment analysis, what does the field look like right now? Because in a lot of the different studies I've seen and papers I've read, even with transformer models, it's still kind of a crapshoot.
I would say for us, I think it depends. You need to, if you use like, let's say, vanilla version of the model, then let's say BERT is not trained to do sentiment analysis, then of course you may not have the best performance there. And also it's not really trained for sentence embedding, let's say, because it's better to do word embedding. And then how do you aggregate them? I would say you need to find, that's why in Talkwalker we collect our own training data, and also we customize our model and for like specific tasks. So in that case, we will make sure that, for instance, for sentiment analysis, we will have better performance than using a model. We just use it, just take it from the shelf.
Gotcha. And do you find that these models, how much human review of the training data is needed for natural language processing models? Is it something? It's not as easy, for example, as like saying, taking e-commerce sales data. That's much easier to model.
So I guess we also, so first we collect, let's say, from some public data sets, and so we know that these data, for instance, are used to build up some benchmarks, so they are relatively reliable, and also we will also may label some data by ourselves. So yeah, we have rather good control of our training data, and yeah, it takes a lot of time to build up our in-house data set. Yeah.
Talk a bit about the mitigation of bias in data sets. You mentioned obviously the debiasing of some of the text itself. Is it a valid approach in natural language processing to keep some of the demographic data and use it as a way to remove bias? So, for example, let's say I have 100 articles by 100 authors, and I have gender information for the authors, and let's say 80 of them are male, 20 of them are female. Is it in terms of debiasing the data set, there's obviously a few different ways to do it. One of the easier ways would be to take, do something like propensity matching, find the 20 articles that are most similar to the women's articles, and only choose 20 of the 80 men's articles. But obviously, you drop out a lot of information that way. How do you think about the mitigation of bias, particularly in the problems that you're being asked to solve?
Oh, that's a tricky question.
It's a tricky subject.
Yes. Yeah. So I guess I have also watched some talks about trading bias, and they said it's always a trade-off between you don't want to remove too much of the demographic information because you will lose a lot of information as well in that case. So I guess it depends on your task. For instance, you can keep all the data and then you do the training and then you test on your test set and to see if you can observe any mistakes, let's say. And if those kind of demographical features really introduced biased predictions, then I would say maybe we need to deal with it. Otherwise, the demographical information, if it provides benefits to the prediction, then we should keep them. Yeah.
Okay. Do you think, though, that, and I don't mean Talkwalker specific, I just mean companies in general, how carefully do you see your fellow machine learning and data science practitioners thinking about bias and making sure that it's a step that they account for in their pipelines and even in their training data?
I think because we are also fully aware of this problem, and so for us, I think we always, when we do data collections and so on, we need to make sure the data sets are diverse enough, and we don't collect, for instance, from a specific domain or specific region and so on. So when we build up our own training data sets, and we are very careful and try to prepare this rather clean and diverse training set.
How do you deal with drift when it comes to models, particularly around dimensions like bias? When, let's say, you calibrated a data set so that it returns the authors that are evenly split 50-50 for gender, as a very simple example. But over time, just by nature of the fact that maybe you're pulling in, I don't know, accounting papers or something, or pick a domain where there's a strong gender bias in one direction or the other, the model will inevitably drift if you just feed it the raw data. How do you deal with drift in models?
So for us, so before we release our models, of course, we will test it in our production environment and using our production data and to see to monitor the performance. And of course, later, if we have feedbacks from our clients that they are not satisfied with the results, and if they see some misclassified documents and so on, and it's always possible to label, for instance, a domain-specific data set, and then using our AI engine to retrain the model.
How effective are systems like reinforcement learning and active learning for these kinds of models in terms of getting feedback from customers? Like if customers just thumbs up or thumbs down an article in the results, how does that work as a feedback loop for retuning models?
So for active learning, I think right now we have, for instance, if we notice that there are certain type of documents or a certain group of documents, they are they are misclassified, and then we would add those examples, particularly we are going to target those examples and then add them into the training set, and we try to learn from those difficult cases.
What advice would you give to aspiring data scientists and machine learning engineers? What are the what things would you warn them about? Looking back at your career so far and things. What are the things that you say, like, oh, look out for this?
Yeah, so I think the first step, of course, right now we have tons of like big complex models out there, and it's very fascinating, and we all want to try them. But at the beginning, I think it is always beneficial to select a rather simple model. It could be even a decision tree model to build your baseline and to understand your data, and also, of course, you shouldn't stop learning. You should never stop learning, because this is a really fast-paced area, and you should always keep up with the recent research. And also, when you see sometimes the results are incredibly good, always double check. Always go back to see, to make sure they are not too good to be true.
What research and things are you keeping an eye on? What things have got your interest that are on the horizon now that are obviously not in production, but that have caught your interest?
For instance, right now, let's say we need to train a model specifically for each problem we want to solve. And of course, GPT-3 gave us this opportunity to do this zero-shot learning, and it can just, we describe our task, and then the model will immediately pick it up and then give us the results. And I think in that domain, there are still tons of things could be done. And also, how is it possible to use or even to downsize such giant model into smaller, manageable ones, and use them in production? It's also a very interesting question.
What do you think of some of the more novel use cases of natural language processing to solve problems that aren't strictly language? There was a case not too long ago where someone took the sequenced genome of SARS-CoV-2, the COVID virus, transcribed it into essentially words, RNA fragments, just the letter sequences of the amino acids, and then used natural language processing to try and predict mutations with a fairly good degree of success. How much do you keep up with the way these models can be transferred from one domain to another?
Yeah, I have seen those kind of usage. I guess you can also, let's say, apply an LP model in the music domain. I think all of these usage are quite interesting, and then it also shows how powerful right now this natural language models are. Yeah, and I think it's definitely, these models have the potential to solve the problems in other domains.
Do you think they'll be sophisticated enough at some point that we'll be able to use them, for example, to restore lost languages?
Yeah, I guess, because I think right now, so these models could pick up, for instance, some similarities between different models. For instance, one multilingual model, if you train them on one task only in English, and then you test it on the same task but in another language, it wouldn't give you like really top performance, but it's also the results are also quite impressive. So I think the model has the potential to to pick up the links between the languages. So yeah, maybe why not?
Okay. And what advice would you give to non-technical folks in particular when they're thinking about artificial intelligence? Because they fall in one or two camps. They either seem to be disbelieving of it entirely, or they think it's entirely magic and can do anything, including create Terminator robots and other things. How do you talk to non-technical executives about what AI can and can't do?
So I think personally, I would say we should definitely embrace the enormous potential of AI, and but also at the same time we need to be aware of the limitations. AI cannot do everything. For instance, right now the models, people are mistakenly think the models tells us the correlations between features, but here the correlations are not equal to causations. So for instance, on Valentine's Day, and if you see, oh, we have rather high price for the roses, and at the same time we have also a very high sale of the roses, and they are highly correlated. But it doesn't mean you cannot draw the conclusion that, oh, so we should, in order to have a high profit, a high sale of roses, we should increase the price, because high price is the cause of the high sale of the roses, which is wrong. So I think here people should be aware of all these limitations, and also when you interpreted the results, how to explain, how to understand the results correctly. It's also very important.
How do you deal with a model like GPT-3, for example? There is no interpretability or explainability of it. It really is very much a black box. Given the interest of governments and things, rightly so, about how machines are being used to make decisions, how do you deal with a situation like that when somebody says, "Well, how did the model come up with this answer?" and you have this black box? What do you tell somebody?
Yeah, so I guess this explainable AI is also a very hot research topic right now. But I guess, for instance, if you look at a chatbot, or you let GPT-3 to write your story, you can read the story and then easily probably tell, oh, this is not really a human written text. It looks, or it seems not consistent, or it rather looks weird. So maybe you can immediately see it's not generated, it's not written by human. So I would say in this case we are still a bit far away from the real, let's say, intelligent machine.
Mm-hmm. Okay. How do you personally, and I guess from a professional and corporate perspective, plan on dealing with the absurd amount of content that's going to be generated by a lot of these natural language generation models, where they're going to create, instead of one really good blog post, they'll generate a million mediocre blog posts that are, that still meet their goals, which is, keyword density or other things, for mostly for SEO, but will flood all of our public commons, I guess, with machine generated stuff that is okay but not great. How do you see companies dealing with just this massive explosion of content?
So I guess in this case, the first task is to identify which text are generated by machines and which are the real, let's say, comments, the real articles written by human. Yeah, I guess in the future, maybe let's say the noise control engine should also try to identify. So this is also one of the major tasks in the future, like to first filter out the machine generated text, and then to find your interested human generated content.
Particularly with comments, though, like on product reviews and things, I foresee that being really difficult, because on one hand you might have a machine generated comment that might have a marker or two, like, okay, that word choice is not how you would normally say something, but it could be somebody who's not a native speaker of that language. And on the other hand, you have comments that are just put up by human idiots. I was reading an Amazon product review saying the other day about a type of apple juice, and they're like, it doesn't taste like fresh apples at all. I'm like, it's not. It's dried apple powder. Of course, it's not going to taste like real apples, you idiot. It's, this human just wrote this absurdly stupid comment on a product. But you could easily see that a machine learning model trying to understand comments might actually think the machine comment was more useful and valuable, even though it's generated but not by a human, than what the idiot human wrote. And it poses this challenge, I think, of the machines might actually write better product reviews, but they're fake. They're not a real authentic review than what the human idiot wrote. How do you see companies dealing with that, particularly a company like Amazon, where you're gonna have people who have a very strong interest in bombarding a product with as many thousands of fake reviews as possible to boost their ratings?
So I guess those machine, like the fake accounts, maybe you could also look at their account names and find some patterns, and also how often they post. You could, I think, from other aspects other than only looking at the text they generated. And also sometimes this machine generated text, they may maybe put lots of, let's say, emojis, or add links and so on. So I guess you need to, if, let's say, we can identify those comments easily, then we should maybe filter out those comments, and then maybe try to study the pattern. And otherwise, if those comments, if those accounts are even difficult for us to identify, then how can a machine identify them?
Right. I mean, that's the challenge I was having. Like, did a real human write this? Because I can't believe. Well, and I looked more carefully, like you said, looking for other reviews, and like, no, this actually was a real, just stupid person, not a machine. Okay, where can folks find out more about you and learn more about you and the work that you're doing?
I think if you want to see my previous publications, I think on Google Scholar you can find me. Yeah, and right now at Talkwalker, we are not publishing like research papers, but I think you can always stay tuned with our product release and see our new products.
All right, and that's over at talkwalker.com, right?
Yes.
All right, thanks so much for being on the show.
Thank you for having me here. It's very nice talking to you.